Uh, my topic for today is continual improvement and lean management. Before entering into the topic, I would like to give a brief introduction about myself. I'm Saurabh Awati, working at Supriya Protech. Supriya Protech is our family business, and currently since 2011, I'm managing the entire industry. I've completed my education. This is about our company. About Supriya Prototech, if I need to tell, we manufacture valve accessories. These are the products that are mainly used in the valve sector. About the valve, if I need to tell, in any process industry, any type of process industry, if you imagine maybe a sugar industry, it may be a steel industry, it may be oil and gas industry, or any process industry, any process line, if there is a valve, for all operating the valve, we need actuators, mainly gear actuators or mainly pneumatic actuators, hydraulic. It depends on whether it is automated or it is manual. For all these valve applications, to open or close the valve, we design and we provide the proprietary products for these applications. About our company, we are established in the year 1991, and this is founded by Mr. S.K.L.E.I.T. We have developed our first proprietary products in 1995. We basically started with manufacturing of gearboxes, quarter turn worm gearboxes, some spur gearboxes, bevel gearboxes, mainly in the operation of valves, mainly in operation of valves. And these are not generic gearboxes, not automotive gearboxes. These gearboxes are dedicated to application in the valve stream. And then we in the site, when there are thousands of valves and there are some identified as critical valves, so these critical valves are very important to understand whether they are open or closed. For such application, we have developed limit switch boxes. These switch boxes tell whether the valve is open or closed. It gives remote indication. Such products also we have. We have even developed pneumatic actuators and hydraulic actuators over the period of time. And one of the very important products that I would like to mention in this forum is we export to Europe with the CE marking of the product. Our product ranges of pneumatic actuators, they range from 4-inch to 40-inch. Very few manufacturers in India are in that particular zone. Maybe this is about the special walls that I was explaining. And a small picture that I have put here, the photo, it might just entice. This is one of the plant where the valves and our actuators have been mounted. Most of the products that we manufacture will get into these process industries. Now let us get on to the most important topic for today's discussion: continual improvement and lean management. In this slide, I'm trying to explain what is Kaizen. We started discussing about continual improvement and lean management, but here I'm trying to address what is Kaizen. But Kaizen is a Japanese concept founded in the year 1950s. All these managerial concepts, what we are hearing right now, maybe Kaizen, Kanban, Six Sigma, or TPS, and many other managerial concepts which are developed in improving the process efficiencies of a company, are all mainly developed in 1950s, 1930s, 1980s. Such historic managerial skills have been developed, and process improvement parameters have been developed, and those we are still trying to analyze and understand these concepts. About Kaizen, Kai means change and Zen means good, change for better. Kaizen in principle, Kaizen means continual improvement. If I have to take an example and explain about Kaizen, in any industry, a raw material has to be converted into a finished product. A raw material conversion into a finished product, or maybe an design of any product, or maybe a supply of any services, all this include the services, all this include a process. Any process that has been oriented will definitely have inefficiencies in the process. The Kaizen means making improvements in the system, making improvements in the processes. Whatever small improvements that we make will collectively translate into major improvements. The incremental improvements that we discussed are a product or process needs to improve percent of yes, the cumulative improvements of 1% of by each employee adds to the 100% of the improvement in the process. Any process improvement or any product improvement doesn't happen overnight. So we need to have a systematic process to do this particular changes. The improvement or the continual improvement or incremental improvements are cannot be just through the top management or mid management or the worker level. It needs to be driven throughout the company. This needs to be driven throughout the company. How should Kaizen be addressed in any company? Kaizen need not be addressed just in the mechanical industry or just in process industry or education industry. Not just that, it can be addressed everywhere. In our day-to-day activities also, Kaizen needs to be built up. If this Kaizen needs to build up in our day-to-day life, only then give try to add some value even when we are doing our work. So what should be Kaizen? Kaizen should be a culture, a cultural change. Kaizen, what we speak should culture. What does Kaizen culture tell them? Culture is like DNA. It should be a culture which values and develops people. Any person or any operator or any worker or any process handling person, if he has to make an improvement to that process, that improvement needs to be identified. For identifying, there has to be a mindset set up into the employees or into the people who are working within the process that there is a need for improvement. Whatever we are doing it to achieve a result, whereas this result can be achieved through a better way. When we analyze that this result can be achieved through a better way, then a mindset of change, a mindset of Kaizen has been inculcated into the people. Such inculcation of mindset, if it is just in the top management or just in the mid management or just in the worker level, it doesn't suffice or it doesn't even help the organization to grow. If everybody in the industry, everybody in an organization thinks about Kaizen and starts proposing about the Kaizen change, start proposing about an improvement, then this particular improvement of small improvements will contribute to the major change product. As I earlier said, 100% improvement on a product or a process or any improvement is not possible overnight. But 100 people contributing to 1% of improvement on a product or a process over a period of time will lead to 100% improvement in the process. This is what is Kaizen culture. Definitely, when we think of a change, there is a risk. If when we inculcate the culture of change, then we need to even encourage risk taking. Risk taking is also very important. When we take the risk, then the change is possible. Maybe when there is a change in the process, it may destabilize the situation, it may destabilize the process. But yes, but the result that we achieve through that over a period of time will definitely help us grow the quality of product or quality of process over the period of time. Let me take a small example here. George Danzig, very rarely heard mathematician, but he is a great mathematician. He's a statistic. He's a statistic student. When he was a statistic student, American. He's mainly an American scientist. During his college days, in one of the incident happened when he actually arrived very late to a class. It was about the class was about to end, and he entered the class. The lecturers were taking the lecturer was taking the class, and there were few problems that were already written on the board, and he immediately started to note down whatever is written on the board, and he copied one, two, or three problems he copied on the in his book, and the soon the class departed, and he assumed that this is the homework that has been assigned to us, and he spent a lot of time in solving this problem. Once after 6 weeks of time, he could arrive a result for that problem, and a neat report was made, and that was submitted to his lecturer. Seeing the report, the teacher was mesmerized by the way he had presented the solution for the problem. When he understood that the problems that were written on the board were an unsolved statistics problem, then the way the solution was arrived, he even earned the doctorate for this. How could this be possible for George Danzig or anybody of us? Maybe he has achieved a real great thing with what he has done. But how, if had it been the other way around, if he had entered the class before, and if he knew that these are the solutions which is impossible to derive, then maybe this would have not happened. So what I want to derive a conclusion out of this is, George has solved the problem because he didn't know that he couldn't. So this is the mindset. This is the mindset. When I explained Kaizen culture, when I explained Kaizen mindset, I wanted to bring out this example because when we feel that a work that we are doing or a process that we are doing, if there is a better way of doing it, if there is a change that when bring it for betterment or to increase the efficiency or to increase the effectiveness, only then we can do some analysis on that and make some improvement. With a great positive approach to solve the problem is what he has solved, and the result was very clear. The impossible problems were solved. Let us come to what is SDCA cycle. It is, we would have heard about, I think everybody would have heard about PDCA cycle. It is plan, do, check, act. ISO, as sir mentioned about college getting ISO 971 certification, the entire ISO 971 certification, it is dependent on PDCA cycle, the plan, do, check, act. PDCA cycle is also similar to PDCA cycle. Here what we do is, any small improvement that is identified, okay, a small improvement that has been identified in a process is identified as a Kaizen event. That Kaizen event, it is identified there. There is a growth in the performance. There is a growth in the performance. When there is a growth in the performance, but repeatedly there is a disturbance set up in the process because workers were all doing a set of activities that was identified to them that they need to follow these SOPs. But due to improvement that was suggested, the performance has gone high, but over a period of time for them to adjust, it takes time. So there is a disturbance. So this SDCA cycle, what it tells is, when a Kaizen event happens, a standardization is important. When any small Kaizen happens, a standardization is important, and that standardization will help to stabilize the process over a period of time. This stabilizing process will definitely give better results than before what we were doing before the Kaizen event. Once this has been stabilized, now again we need to have a thought process of what is the next improvement that can be made in this process. When that improvement gets identified and again it gets implemented, then another Kaizen event occurs. When that another Kaizen event occurs, again there is a change, again there is a disturbance in the process that needs to stabilize again. So that is what this graph tells: a Kaizen event and then standardizing and sustaining. and then again Kaizen event and standardizing and sustaining. This is how any process or any activity needs to be improved using SDCA cycle. So PDCA we have already heard, that is how plan do check act. Engineering industry or any type of industry, we definitely work on plan do check act. Even when we are designing a product, even when we are trying to redesign a product, every time we come across this SCA cycle, every time we come across the PDCA cycle, and we bring a small change or change in the performance or change improvement in the quality. Similar to that, let me even explain the SDCA cycle by taking an example with innovation and Kaizen. Innovations are definitely imperative for growth of any industry. That is well understood and well accepted by everybody. But when any innovation happens, okay, innovations happen over one time, and once the innovation happens, there is definitely a growth in the product quality level or process quality level, or maybe even the product. The improvement can happen. When that innovation happens over a period of time, if we don't understand the drawbacks, if we don't improve upon the processes, if we don't improve, over a period of time, or there may be changes that happen, that may happen within the technology, in the process, or maybe the new methods needs to be implemented. If that is not done, you can trend of the curve without Kaizen, how the downward trend is a quality level over of time. But with small Kaizens, with after innovation, if small Kaizens are done, everybody who are involved in the project, or everybody who are involved in the product, Kaizens will definitely, small improvements will definitely increase the quality of the product. And then later, another innovation will definitely take the quality of the product to the next height. This is how we can understand important is every important for us. Kaizen the helper that he does, how so we have we have understood about what is continual improvement. Continual improvement, actually Kaizen and continual improvement, they are the synonyms. And we have understood about briefly about the improvements and other things that continual improvement can be brought in processes. Now let us understand what is lean management. There also we have discussed about there is different. Lean is nothing. It's in the concept of process waste. Any process that happens, there are lot of things that may happen where the unnecessarily we will be waste our energy. Unnecessarily the wastes are getting generated, but a process completed in a efficient way or in a very effective way, minimizing these process waste is of utmost importance. That is how the lean management has gained importance over a period of time. Okay, only when the concept of I have lean maybe in 2029, 2012 we implementing, I have heard, but actually the lean was bought by the Fords. They started manufacturing the automotives. They started implementing the lean production systems, how to minimize the waste. All these managerial techniques have been developed. Sir, there is some disturbance. Hello.
Hello, tell me, sir.
audible?
No, sir. Audio is very, very poor.
Even now is the audio very poor, sir? Was it poor for the entire duration, what I was doing?
No, 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 sir. Now just 3 minutes it is very poor. Since 3 minutes it is
Huh.
very poor.
Okay, now I think has it resumed back, sir?
No, no. Still it is not resumed back.
Okay, okay. Let me check the internet connectivity.
Here, Banu. Here, Banu.
Sir, is it better now?
Ah, yes, sir. Yes, sir. It's better now.
Okay,
Okay.
I will try to. I'll continue, sir. The moment you feel there is a volume down, you can just
Yeah.
intervene and let me know.
Yes, sir. Sure, sure. I'll let you know.
Okay.
Okay. Yeah.
Yes, sir.
Please continue, sir.
Yeah. So I was explaining about the Ford's original thinking. Ford has actually thought about this in 1840s or 1860s when they started manufacturing the first automobile, and they actually didn't give a word called lean for this particular thing. But when the Toyota production system management TPS cycles came out, the Toyotas actually benchmarked the Ford's original thinking, and then they brought out the word called lean production. This is how they benchmarked it. That's why Ford's original thinking is very similar to Toyota production system, which gave rise to lean production. So we generally speak about the process in the process approach. We speak about continual improvement, and there I would like to highlight about in what is continual improvement and what is continuous improvement. There is a lot of difference between continual improvement and continuous improvement. Maybe we would have understood it in the SDCA cycle what we have highlighted. The small improvements is continual improvement, whereas continuously keep on improving is continuous improvement. It is like go, keep on improving. So, but this in an industry, in any organization, continuous improvement will never bring value to the production, because any improvement that has been made, it needs to stabilize, and we need to check the value, and only then the next improvement needs to be suggested. So in the process approach, we need to understand this, and then we can come to the waste management or how to reduce the waste. In lean strategy, we generally, how we inculcate the continual improvement process. Similarly, the lean strategy should be there in all the activities that we perform. The activities may be including our the process of design. When we are trying to design a new product, how can we make this design more efficient? How can we include the present working present models, or present developed assets, or present developed jigs and fixtures and machines and currently available vendors within that surrounding system. How best can we put our energy, and how best can we manufacture this product, how best can we design this particular product? All this, in every process, in every step, we need to think about lean. The lean is definitely a strategy. The strategy is to reduce the waste. It is to identify the problem and reduce the waste. Let us come to a simple cycle, lean manufacturing cycle. It may be here I have just taken an example where customer gives an input and we need to map the stream, but it can be applied anywhere. We identify a specific value, maybe identify customers, there we identify value, or identify a process, there we identify a specific value. Then we map the stream. What is the stream? What is the path that we need to take? And then we create a flow by eliminating the waste. So waste elimination is going to be supreme in lean manufacturing. And then we respond again, we pursue, and this is the process. In the process of eliminating the waste is lean manufacturing. In lean, when we discuss about the waste, there are three enemies actually about the lean. This is how colloquially it is being said. There are three enemies of lean. One is Mura, one is Muri, and one is Muda. Let me explain about Mura. It is in simple words. If I have to tell pictographically, also it has been shown that it is unevenness. Unevenness in relation to what? In relation to production environment. Let me give a simple example of our own industry, where the valve industry, where we manufacture these actuators and gearboxes. It concerns to low volume but high product variation industry. There are a lot of variation in the products. A valve manufacturer can give us a target telling this is the size of the valve, and this is the thrust, and this is the torque, and this is the operating time within which the valve has to open or within which the valve has to close. Maybe let us say an example of 100 kilonewton thrust has been taken and 100 travel. Uh, for this specific project, we design the whole product and we offer the solution to them. Immediately, another customer may ask us the similar product, similar stroke length, but the thrust value may be around 10 kilonewton higher. For these, even 10 numbers of this or one number of the product, we need to go through the entire design cycle, entire manufacturing cycle. So the product variation here is higher, whereas the product volume will be very low, whereas the product variation is very high. Maybe we might discuss about, can we not standardize the products? It is possible. Definitely it is possible to standardize the product, but we may gain an advantage, we may lose an advantage. We may gain the order, maybe a competitor might take an advantage over the price, and we may lose the order. That is why the high product variation is accepted in this particular industry, and we design the product every time. Even the low volume is also accepted. In such production environments where there is low volume and high product variation, the flexibility is more important. How we need to be flexible, we need to accommodate these things. It is not like we start we release a drawing and we manufacture that product for next 6 months. It is impossible in our industry. But whereas such a high volume and low product variation is definitely possible in automotive industry. Suppose a vehicle gets launched immediately and they start manufacturing one part or one engine or any headlight or any component in lakhs together they manufacture. There it is high volume and low product variation. These type of unevenness is definitely possible in all industry. Where there is high volume, there will be low product variation. Where there is low volume, there will be high product variation. Such unevenness is also enemy of lean, because there are the problems related to this. Suppose an automotive industry has recently launched a vehicle, and they have already stocked around lakhs together of pieces so that they can manufacture, and immediately due to some approval or due to some problem the vehicle gets stopped in the production. So that particular inventory is going to be an enemy of lean. Okay. Similarly, in volume also high product variation, we get a lot of examples over there. So this Mura, that is unevenness, we need to reduce, we need to dampen the unevenness. But it cannot be dampened to a zero level, but it needs to be dampened. What happens if we try to dampen it to a level below what is possible? We directly overburden ourselves. We overburden, so that is when unevenness will die and overburden, that is Mura, will go and Muri will start. Muri is overburdening. We start overburdening our process, we start overburdening our people everywhere, and that itself will start costing to the company. Unevenness will also start cost to the company, overburden will also cost to the company. Okay, but having a stabilize, or having a small a thin line of difference between these both, and that is the area where we need to deduce, we need to have theoretical calculation, maybe statistically we need to understand what works, what doesn't work, financially what works, what doesn't work. Everything should be understood, and then we need to deduce how lean production can be adopted in any industry. Then comes Muda. Muda is nothing but waste. It is about any process has waste, as I've explained, but to simply to categorize the type of waste under Muda, there are 7 wastes that have been categorized. Actually, there is another one waste, 8th waste. 8 wastes have been categorized, and the 8th waste is very recently categorized. I'll explain about the types of waste going forward. So in lean concept, we understood Mura, we understood Muri, and we are trying to understand what is Muda. Mura should be reduced. If it is reduced to a level below what is acceptable, we will overburden. Similarly, Muda is also similarly. We need to reduce the waste. We need to reduce the waste, but the reduction of waste might hamper the system. The reduction of waste should be done to a level where it doesn't overburden us again. So Mura done in a controlled manner will only give us results. Muda also done in a controlled manner will only give us results. If both Mura and Muda, if they are uncontrolled, then we will be overburdening. So these are the three enemies of lean. There are multiple examples. There are thousands of examples where practically I think even without taking the names of Mura, Muri and Muda, every company will be working on this, every organization will be working on this. Maybe if we try giving a shape to this by giving these names, or by deducing the results with some statistical calculations, by having some data analytics, if we can do, maybe we can gain better results. That is when the segregation of waste will happen. What are the types of waste? How can waste be classified? What all industries can be classified with what all waste? That is when these discussions start happening. And these waste are generic. It can be applied to any process, any industry, any organization. These are the types of waste. Let I have just listed down the types of waste. Then I thought, let me put some examples to this, to what we have done to eliminate these wastes. Okay. First one is overproduction. For example, when it is example I've written as castings order. What we used to do when we receive any order for 10 numbers or 20 numbers or 50 numbers of any product, we used to always keep a safety margin. If it is 10 numbers, we used to order 12 numbers of casting. If it is 50 numbers, we used to order 55 numbers of casting. There may be a calculation of 5 to 10%. Every time we used to order it in excess. And this excess of castings that used to come to us would always remain with us as a dead stock. If we get those orders again repeatedly, then we may use the casting. But the valve industry works in a different way. If there are projects, then we can use. If the project is of the same size of actuator, then I can use that. If there are some again tailor-made products, then we cannot use. So this overproduction was actually burdening us a lot. The orders that we were giving for casting, and the price that we were paying for them, and the machining charges, everything was really burdening us. So we identified this, and then we took a step of improving our vendor. That is one. Why were we ordering more? Because if that casting gets rejected. So first we need to eliminate that. We eliminated that by taking the process control, even by taking the confidence of the vendor. We tried to analyze why, when, and in which condition, when the casting might fail. So what care he can take, and all those things. When we identified the rejection of castings, when we literally calculated, they were around 1 or 2% of the castings were getting rejected. For that, we were burdening our entire organization with every ordering excess of the castings. That was the waste that we have eliminated. And next is about waiting. The waiting, there are a lot of examples that I can give. One simple example what I can give is, in any product that needs to be manufactured, we will have a bill of material. In the bill of material, there are long lead items and the short lead items. The long lead items, if we order it today, maybe we might get it in 6 weeks of time. And the short lead items, maybe we might get in a day or two, or maybe 1 week. Suppose if we order the long lead items and short lead items at the same time, immediately, then the short lead items will come to our factory, and we need to finance for them. We need to pay the vendors for that. And those items will be waiting for the long lead items for the next 4 weeks, next 5 weeks. So there is a loss of interest. There is a shrink in the working capital for the company. And these are the problems. So we literally identified what are the lead time of each item, and what are the long lead, what are the short lead, how each order needs to be planned, and how each order needs to be ordered. So that is one of the typical examples for waiting. We have taken care. There are some nuances over there, but yeah, it's a continuous process. Continual improvement is a process again. The next immediate waste is transportation. In our case, we have two industries, one in the city, and another is around 5 or 6 kilometers away from the city. We were doing, we had only one paint shop that was away from the city. Every product, every part, which if it needs to be painted, we were taking it 5 kilometers away and then getting it painted, and we were bringing it back. So this was one of the it was a Kaizen was identified, and waste elimination in the lean improvement strategy was made, and immediately the paint shops were two paint shops we immediately made, and such transportation waste also we could do it. We could identify and eliminate that waste. Next is about the process inefficiencies. In our bar cutting shop, the round bars, square bars, and pipes cutting shop, there was a equation of cutting the length 6 or 10 excess to what is mentioned as the finished length in the drawing. So when we actually saw, we were cutting these bars using the bandsaw machine. So bandsaw machine is highly effective machine. There is no bend after the cutting. There are no bends. Whereas in hacksaw machine we get that, in bandsaw it is not. So when we analyzed, just 2 or 3 mm of excess material for turning operation was sufficient. But we were doing around 8 to 10 mm. When we calculated this particular process inefficiency and when we accumulated it to what loss we were making, it turned out to be a lakhs of rupee of loss in 1 month sizes. So when this was identified, it was a great. It was like we are one an additional margin over what the product we were doing. So such inefficiencies we eliminate. Mm, we have done this. Such process inefficiencies were there in other products as well. This I felt is worth mentioning it here. And inventory and storage, this is most critical. We play very little with this inventories and storage, even though we identify that there is a waste over there, but it is a kind of risk to eliminate that, because a stock out case, if there is no item in the store which can feed the assembly line, such stockout case will lead to disasters in our assembly lines, in our lot of our processes, lot of our plants, steel industries, and the paper pulp industry, oil and gas industry, and mining industry. They need the replacement of products or actuators within no time, and they need just in time. When we have to cater to those industries, then the stockout cases is going to be impossible. We should eliminate that. That's why we play very little with this inventory and storage. Definitely there is a calculation how we maintain the stock. That is why I have written it as Kanban replacement. We have made a Kanban stock limits, and that is how we maintain it. And so unnecessary motions, we again drilling and special boring, the layout planning and other things, there was unnecessary motions. A small improvement. These are all 1% improvement, or maybe 0.5%, 0.5% improvement. But together the value that we generate out of it is huge, is literally huge. And defective products. To eliminate the defective process, we have the kappa process. Kappa is corrective action and preventive action. For every complaint, for every defective part, defective product, or any non-conformance that is arrived at in a machine shop, maybe in an assembly shop, or maybe even the NC that comes from the site, the complaints that comes from the site, all for the defective products, we make a kappa report. We make a corrective action and preventive action report. So that is a process control that we make. We understand what is it that was a mistake and what is the improvement that can be done. So using those cases, we even categorize whether this particular complaint is serious, whether it is repetitive, whether it is non-repetitive. Based on that, we try to eliminate the waste. Now we have understood 7 wastes. The 8th waste is going to be really the most important. We were only discussing about the 7 wastes, but when we heard the 8th waste, within no time we generated value in it. The 8th waste is nothing but unused talent. Here it is written waste due to underutilization of people's talent, skills, and knowledge. Yes, we had our skill improvement training for our workers, that was in line. But one unsaid thing or unwritten thing I would like to mention here: unused talent. We implemented this to all our vendors. Lot of vendors with whom we were working, a lot of subcontractors and vendors. We have 100 to 150 vendors with whom we work, and all these vendors with whom we work, maybe around 10, 15 years, we were working with only one type of product. We used to always buy that kind of product because we had approved them only for that product, and they used to keep supplying. when we heard of this eighth waste, when we discussed of this, we thought of understanding what other products our vendors or our subcontractors can process and give us. How can we take the best use of them? So that is when we, instead of developing new vendors, which is more costly effort, because we need to develop a vendor, we need to give them orders, we need to approve them. There is subsequent many number of visits should happen well, from their side, from our side. But we already know a vendor. We already know his quality level. But developing another product from him or another part from him, the linear integration from them was very easy. This eight ways, we unused talents, we started using them. A lot of improvements came forward. People who were doing X business with us started doing 2x business with us, 1.5x. But there was an improvement. Even our vendors liked that strategy. Okay, this is the type of waste which we were doing it since 15 years. This we could change, and even this is a process. Every day it happens. Okay. Next, let us go to application and takeaways. The takeaways here, if I'm not wrong, maybe I have a lot of our faculty friends in this presentation. The takeaways or the applications that I would like to tell them is Kaizen and Lean. I think you would have already heard of the Six Sigma. The Six Sigma is again a similar approach. The Six Sigma, there are a lot of certification courses. Maybe the green belt certification, yellow belt, black belt, the supreme. These are all the certifications that any person who is interested in Six Sigma management quality control, they can undergo this particular certification course and they can get themselves certified. Similar to Six Sigma, there is Kaizen and Lean production method certification courses as well. I would like to tell everybody to kindly promote the students to pursue these courses even during engineering, because the way we look at things, when we get engineers, when we hire engineers, we would be happy if the engineers are able to look at the process, look in the designs, or look in every aspect of their everyday work, but through these lens, through the lens of Kaizen, through the lens of lean management, through the lens of Six Sigma protocols, everything. If they are able to see through that, then the company can grow, they can grow. There'll be a lot of value addition. There'll be a lot of value addition. In line to this, we have even given a lot of projects to the engineering students. Even through K.L.E.I also, a lot of students keep coming to us, and we have given a lot of projects to them. Very similar, very recently, one of the project we were doing hydraulic testing of linear actuators. And if the size of actuator is 1 inch, 2 inch, and 3 inch, it was the test strip that we had was very well and it was fine. When the actuator size increased to 10 inch and 1500 length, and such time we were wasting almost 1 hour to 2 hours in testing one actuator. So a Kaizen improvement was identified. We immediately gave a project, and K.L.E.I students have done a very great work in this particular project. And we have recently done one small improvement. What was happening in 20 minutes, we have brought it to 3 minutes or 4 minutes. So that itself is a great step. Now we would like to bring it to seconds. That is the third improvement that we will be doing it. Next, next Kaizen project, which was done by one of the SDM student, was during when we took our CPD approval. This is the conformity to European directives. PD is the pressure equipment directive. Our product is certified under pressure equipment directive. The Kaizen improvement project was given to one of the students, and he has done a beautiful documentation of it. And currently, still project is going on in our company, and that also we are very interested to share it with students. And now let us. I've already explained about Six Sigma. I have okay, QMS and everything. We have taken it up. Okay, let us go to one of the case studies. I have considered 2 or 3 case studies. Let me explain one. I've explained this in brief in one of the slides that we had taken it up. Let us understand the inspection, the current method of inspection, or what is it that is expected when any inspection has to happen in any product or in any item when it gets manufactured. the inspection that should be done is not just dimensional. Currently, what everybody does is when we get the engineers start doing the inspection, they just look into the dimensional part of it. Dimensional part is one category of inspection, but inspection leads to should be done by understanding the quality inspection parameters. Like lot of quality inspection parameters, maybe these may be standardized because every product that we manufacture, either it conforms to ASTM standard or DIN standard, or it conforms to ASME standard or AWA standard or GHOST standard. There are many standards that are applicable, and understanding the parameters and what are the results that we need to achieve, comparing these results with the standard results, and then deciding whether this product or whether this parameter is right. There are some set of characteristics of parameters that will be listed in the drawing. There are some characteristics which will not be listed, but every aspect of that inspection needs to be looked upon. To fill this gap, we identified this gap when any inspection was happening. So to fill this gap, we made a new training manual, new quality training manual and sampling methodology manual. And this became a kind of the minimum course that any engineer who comes into our organization should go through this course and try and explain what are the inspection parameters and how kappa needs to be done.
Sir, Saurabh
Yes,
sir.
sir.
Hello. Sir, there is a small disturbance in audio. It's not clear now.
Yes,
Just
sir.
now.
Okay, okay, great, sir. Thank you, thank you. Sir, is
Yeah.
it clear now, or should I change the position?
Yeah. Now it has become clear, sir. Now it has
Oh,
become clear.
okay, okay. Thank you, sir. Thank you. Thank you. So I was explaining about the corrective and the preventive action. Generally, when any complaint, when any customer complaint we get, or any small non-conformity in the production or in the shop floor is identified, we regard to it as an improvement step. So we identify what is the quick action that needs to be done. Once the quick action has been done, we need to identify what is the correction. The quick action may be immediately we solve that problem so that the site conditions will not be hampered or the production will not be stopped. That is the quick action. And the correction will be why is that has happened, or the corrective action. The corrective action that we take is why that particular NC was found, why this NC has happened. That is the corrective action. Any corrective action when we implement, we need to do the root cause analysis. A corrective action, the reason cannot be found out just simple. It may be we might just tell the operator has done some mistakes. So every time we telling that the operator has done a mistake is not right. Why did the operator do the mistake? What is that has happened? Was the instrument calibrated? Was the environment flexible for him to do the quality of the product right? Was the timing of his work right? Everything, that is what we call YY analysis. We do YY analysis for every complaint. Any corrective action that needs to be done, we do a YY analysis, and we even draw a fishbone diagram. With a fishbone diagram, we try to understand what is the root cause analysis. When the root cause has been found out, we try to implement this root cause with the corrective actions. And once the corrective action for this particular problem has been identified and it has been solved, then we try to do a preventive action. There is a lot of difference. There is a lot of difference between corrective action and preventive action. And this is what is the minimum that we expect the engineers to know. The corrective action is implemented on that product, on that part, whereas the preventive action is applicable to any other such parts which we are having in our industry or in that shop or in that particular design. Maybe 4-inch actuator had some problem. Can we apply the same corrective action to 5-inch, 6-inch or 10-inch? Can we harmonize that entire the correction that we have done? This is preventive action, preventing the further damage in other sizes. So this corrective and preventive action report is the most important thing. That this is one of the key parameters in lean management. This is a type of eliminating waste, and it is a type of continual improvement. Okay. And once we have identified that this is the correction or this is the preventive action, it is not just identification, but implementation is most important. Once that particular cause has been implemented, maybe a change in drawing, change in material, change in the process parameter, change in the instrument, anything. It may be anything, man, machine, method, any change can be there, environment, and any change. When that change is identified and it has been implemented, the verification of the non-conformity adherence is also should be checked. That is control of process. The control of process parameter should also be checked. Then the final report will be made that such a complaint had arrived and corrective action has been taken, the correction has been implemented, and no further NC has been found in few cases. And that is where the final report and closure happens. This entire cycle of quality inspection should be known and should be the DNA of every mechanical engineer, who just come to, who just are eager in joining any process industry or engineering industry. This should be the core. This should be the core. Is what we identify. And most importantly, our training manual has actually solved a lot of our problems that we were doing it through other type of trainings. It has really helped us a lot. Okay, let us go to another case study. This case study is outside our company. I felt it is worth explaining. Okay, it is half-thrown experiments. I've read it in one of the book, and I've collected it long back, maybe from 4 or 5 years. This was in my book, and I like this particular experiment. This particular half-thrown experiment was done in a Western Electric company, where they used to manufacture some product. I think they were doing some textiles, or they were manufacturing some product. It was a line production, and the management of the company decided we have to do the productivity analysis of all these employees. There were thousands of employees. When there are thousands of employees, it is highly labor intensive, highly human resource intensive. There, the more than checking the raw material prices, they target more on employee productivity. So employee productivity was identified, and they immediately identified, let us study the effect of lighting, the shop floor lighting, or the place where they were working. Let us study the effect of lighting on the employee productivity. So immediately the management decided, let us increase the lighting. Maybe the illumination was to 1 degree, they increased the lighting. Okay, in one of the floor, in one of the work area. Immediately when this was done, they felt the product. It was measured. It was measured quantitatively and qualitatively. It was measured. The productivity increased immediately. Okay, within a matter of time, maybe 15 days or 1 month, the productivity increased. Further, what they did, they changed to understand whether the lighting is actually making effect or something else is making an effect. To understand that, they brought the illumination level to the earlier level. When they did that, in the subsequent month, the productivity further increased. This increase in productivity, even when the illumination was brought to the original, literally made the point to be thought, and what is it that is making the increase in productivity. So that driving mechanism is what the entire management started to find out. They again tried different types of experiments on on that work area and multiple work areas. Then in some, the workers were even given greater job variety and freedom to decide how you want to do it. You can just design your table, you can just design your workplace, and you can design your work content and do it. This even increased their productivity. So what the Haskell experiment has actually globally given lot of address in big even it's a case study that is even discussed in Harvard. So what they discuss is the continual improvement and the freedom of change, and that feeling that we are being watched, or we are being there's a energy, or there's a change that is being expected, or there's a positive energy that is being given by the management. Such thing will bring out lot of productivity increase. That is what is the conclusion. The continual improvement, freedom, change, and positive energy is beneficial to the employees and organization. I have just put a small screenshot of the report, how they have done the analysis of illumination versus the productivity, how they have done. I've just collected this. And based on this, there are a lot of papers that were identified, and a lot of this was implemented not just in this industry, in many other industries. This was identified and it was implemented, and then the result was same. The result was very similar. There has to be a change in the type of work, change in the process of work. There has to be a continual improvement in the way you work. If there is a small continual improvement, then the productivity of employee is going to go very high. Okay, so lean management and again continual improvement, that comes everywhere. Okay, so let us try to go to the third case study. This is an unforgiving assembly line. This was I think this unforgiving assembly line was in 1940s. This was in 1940s. That's Henry Ford. He had implemented a beautiful assembly line to manufacture the automobiles. In the automotive industry, even now, when you see the assembly line, there's a line of assembly where the people assemble these parts in a way that has been pre-decided. It has been pre-decided and pre-trained in the same way the people start doing the assembly. Okay, this unforgiving assembly line, what it tells is that each worker who were doing the tightening of bolt or who were doing some spot welding, they actually repeated that job for 10,000 to 20,000 times a day. In one day, the same work. If someone is tightening a bolt, he keeps tightening that bolt, number of different bolts for 10,000 to 20,000 times. Okay, if someone is doing a spot welding, they do that for 10,000 to 20,000 times a day. When this was done, they found a major psychological and physical problems in these.
Hello, Saurabh sir.
Yes, sir.
Screen is not visible. Hello.
Yes, sir. 1 second, sir.
Screen is not visible.
Let me check, sir. 1 second.
Personal ಮನೆಗೆ ಸ್ವಲ್ಪ ತಗೊಂಡ್ಬಂದಿದ್ವಿ ಕಾಲೇಜ್ ನಾಗರಾಜ್ ಅದು ಕೇಬಲ್ ತಗೊಂಡಪ್ಪಿ ನಾಗರಾಜ್ ಅದು ಇದು ಕೇಬಲ್ ಇದಮ್ಮ ಅದು ತರ ವೆಬ್ ಕ್ಯಾಮ್ರಾ
Sir, is it visible now?
No, sir. Yeah, now it's visible, sir. Now it's coming. Yeah, yes, sir. Yes. Okay.
Yes. Okay. What I was telling was around the workers repeated this job around 10,000 to 20,000 times a day, and there were major psychological and physical problems that was revealed in the workers who were working in this assembly line. The actual problem was the work that they were doing was highly repetitive and it is monotonous, only single type of job, to an extent where they needed an external command for them to even go and use the restroom. They were waiting for an external command. After every 20 minutes the command comes, and then that is when we are we are going to go and use the restroom. And this type of the control over the human behavior through an external command had actually created a lot of psychological and physical problems to them. This highly repetitive and monotonous work and a feeling of helplessness. Only when there is a command we will do this action. Only when there is a command we'll try to use this. This type of thing, it was actually dehumanizing them. It was alienating them. It was dehumanizing them. This everything was externally controlled, including visits to the toilet. This is a main important point that has been highlighted in unforgiving assembly line. The repetitive and dehumanizing work, nature of work, in many situations affects the employee's productivity. There has to be a change. If someone is doing type A type of work, his skill needs to be improved so that he does type B type of work also. There has to be a change in the way he works so that his productivity increases, and for us the efficiency in the process also grows. So that was the conclusion that the unforgiving assembly line was giving us. Okay, so let us consider. Okay, I think this was the end of the case studies and my presentation. I would like to, if there are any. If there are any questions, I would like to note down,
Yeah.
or
Any doubts, anyone, if you have, you can ask directly to the speaker.
if I'm capable of answering now, I'll answer it, or I can even make a note of it. Please ask me a question.
Even you can contact him through phone or through email. There is no issues. Okay. I think it is a time to conclude the particular session. It was very good information by Saurabh sir.
Thank you.
Continual improvement. He explained many things about STCA cycle. Then there is no limit for continuous improvement or continual improvement. Lean strategy, lean manufacturing, enemies in the lean, and root cause analysis, corrective actions and preventive actions. When he has given good case studies, uh, I hope all the participants got good information about the industrial exposure. Thank you, one and all. We'll meet again tomorrow, again at the same time, with a different speaker from Sandvik Asia Limited, Pune. Thank you, one and all. Thank you, sir. Thank you, Saurabh, sir.
Thank you very much.
Thank
Yeah.
you.